Hello, I'm Architect Martinez Chung, and in this lesson we will go over the four forces acting on an aircraft. So there are four forces acting on an aircraft flight. They are lift, weight, thrust, and drag. First off, we have the force of lift. This is the upward force that sustains the aircraft with flight. It's essentially what allows us to fly. Now, how is lift created? In order to understand this, we need to understand what's known as Newton's three laws of motion. First, in English, essentially what this is saying is an object that is moving will keep moving until it is pushed in any direction. Same with an object that's not moving, it will stay there until it is pushed. Next up is the second law. The second law is best stated through the formula F equals ma. It means that the force that is being applied to an object is equal to its mass times its acceleration. And finally, we have Newton's third law of motion. It is for every action there is an equal and opposite reaction. You will see how that works in just a sec. Another law we need to know is what we call Bernoulli's principle. Bernoulli's principle states that the total energy in the system remains constant, and if one element increases, the other one must decrease in order to counterbalance it. Okay? Essentially, what is happening is whenever you have an increase in something such as, let's say, pressure, you need to have a decrease in something else, such as velocity. And same thing, you have an increase in velocity, you need to have a decrease in pressure. This is how lift is generated by a wing. You see, the shape of the wing makes it so that the air going over the wing is going much faster than the air going under the wing. And as per Bernoulli's principle, that means that the air going on top, where there's a higher velocity, needs to have a lower pressure. And same with the air going below it. Since it has a lower velocity, it needs to have a higher pressure. Therefore, you end up having a high pressure at the bottom of the wing and lower pressure on the top of the wing. And the result is the high pressure keeps pushing on the wing, but the low pressure on top can't keep it down because it is low pressure. Therefore, the result is the wing goes up. And that's why we have lift. Downwash. Now, this is where Newton's laws apply. Alright? So downwash is the flow of air downwards, essentially. Okay? How this actually applies is thanks to Newton's third law of motion. So let's say you have air particles going towards the wing. What happens to the air particles once they strike the wing is they're deflected downwards. The resultant force is a force upwards and in the same direction the air particle was going, which we call drag. Next up, we have weight. Weight is a downwards force due to gravity, directly opposed to lift. Right. The weight of an aircraft acts on what we call the center of gravity. This is the single point where essentially we're adding up all the different weights of all the different parts of the aircraft, and on average, most of the weight capacity acts on this single point. Just makes it easier to measure, like safety limits and load factors. Okay? For the purposes of this course though, there might be some confusion between either weight or gravity, but for this course, we'll just call it weight. Next up, we have thrust. So thrust is the force exerted by the engine and its propeller, which pushes air rearward, and the result is the object is thrown in the forward direction. So in English, or a better way to think about it, is think of it like you're swimming. Whenever you're swimming, you're grabbing on a bunch of water and pushing it back. And the result is you move forward. It's the same thing with a propeller. A propeller grabs a piece of the air and throws it back. And the result is the airplane moves forward. Okay? Propellers can work usually by moving a large amount of air at a very slow speed. Whereas jet engines, they move a small amount of air back at a relatively fast speed. The thing to know with this is the effect is the same. And here's why. So if we look at Newton's second law of motion, F equals ma, And let's say we'll start with the propeller. We're moving a large amount of air. Therefore, we're going to have a big M. They're moving at a relatively low speed. And there we have a little a. Alright? So we have big M, little a. And that equals F. Let's start with that. Then let's move on to jet engines. Right? So jet engines have a small amount of air push. Therefore, they get a little m. And that small amount of air is pushed back really, really fast. That makes it a big A. So now, each of both formulas have a small letter and a big letter. And in the end, both balance each other out. Drag. Drag is resistance in aircraft experiences when moving through the air. So this can be related to what we know as friction. However, since we're moving through a fluid, then the proper terminology is drag. There are different types of drags that we will discuss here. Alright? The two main types are both parasite drag and induced drag. Parasite drag is the name given to all the parts of the aircraft which do not contribute to lift. So, fuselage, landing gear, antennas, pilot's cockpit. And then we have induced drag. So, induced drag is caused by the parts of the aircraft which produce lift. Alright, so usually the wings. And the thing about this type of drag is it's always present and cannot be eliminated. Alright? One thing to keep in mind is whenever you have more lift, you will have more drag as well. They go hand in hand. First, we'll go over parasite drag a little more. Parasite drag can be further divided into two components. First, we have foreign drag. This refers to the drag created by the actual shape of the aircraft or the body of motion. Okay? In order to reduce this type of drag, we can do something we call streamlining. Alright, in streamlining, we can take, for example, we take a very blocky object. As air hits the blocky object, it creates a lot of drag. It just keeps the air from moving forward. However, if we replace that with a smoother object, then air tends to flow around it more easily. And that's how we streamline. And next we have skin friction. Right? Skin friction refers to the tendency of air flowing over a body to cling to its surface. Right? So, aircraft accumulate a bunch of dirt, mud, ice, bugs all over their wings, and those can create a little bit more friction to the point that the air kind of sticks to it a little bit, creating some drag. Alright, another type of drag, we have induced drag. So as we discussed earlier, the greater the lift, the greater the induced drag. Alright? Again, this is because if you actually look back to our model that we developed using Newton's third law of motion, one of the forces that comes from the air particle striking the wing is a force backwards, so towards the back of the airplane. And that's drag. If you have more and more lift, essentially you have more air particles hitting the wing and being pushed downwards. The result is, obviously you have more force going upwards, but you will also have more force going back. Okay? Another thing to note as well is sometimes airflow under the bottom of the wings tends to flow outwards, while the airflow at the top of the wing flows inwards. Alright? This is like a three-dimensional picture that you have once you realize that the bottom has higher pressure. Therefore, the air below the higher pressure will tend to spread out, while the air on top, which has lower pressure, will tend to come together and converge. Eventually, the air below tends to spill over the top, creating what we call wind-tip vortices or eddies. Alright? So these eddies are chief contributors to induced drag. Essentially, when you have more eddies, the more drag you have. Alright, and that's it. So, if you have any questions, comments, concerns, queries, or random outbursts, feel free to put them in the comment section down below. Thanks for watching and happy landings!